مرحبا، معكم مهندس نوارة من شركة ECC. واليوم بنكمل على فيديو ال Piping and Instrumentation Diagrams. هلا احنا شرحنا بأول فيديو ايش هم ال P&IDs وتصنيفاتهم ايش متكونين وهاي السواليف. بعدين سوينا examples. احنا حكينا قبل انه المايكروسوفت فيزيو is the program we use احنا نرسم ال P&IDs in a professional way. أول شيء سوينا الكمبرسور، سوينا الهيت اكسشينجرز، وسوينا الرياكتور with the cooling jacket. اليوم بدنا نعمل اللي هو الابزوربر. هلا الابزوربر it has multiple control loops, whether it was the pressure control loop أو حكينا إحنا اللي هو level control loop. كمان عندنا concentration. But this is what an actual P&ID of absorber looks like. Let's zoom in a bit. So احنا عندنا الابزوربر وعندنا الكنترول لوب اللي هي تبعت البريشر، وعندنا الكونسنتريشن، وعندنا كمان اللي هم الليفل، وعندنا هذول الانديكيتورز. هلا خلينا نرسمهم كلهم على ايش؟ على المايكروسوفت فيزيو. اول شيء بدنا نفتح الفيزيو. اوكي، basic diagram. perfect. هلا المايكروسوفت فيزيو اول شيء ما حيعطيني كل الشيبس انا بدي اياهم، فشو لازم اعمل؟ راح اعمل more shapes، وراح احط engineering، راح اختار the process engineering. In this case we are going to need vessels, we're going to need instruments, we're going to need pipelines, we're going to need valves and fittings, and I think that would be it. بس بنشوف وجنرال I think. فاول شيء بدي احطه هو a pipeline اللي هو valves and fittings اللي هو الداخل على الابزوربر. مبدئيا here's a pipeline. I would need more than a pipeline, more than one pipeline. So هاي أول pipeline. Give me a second. Okay. So in here, let's copy this so we have a reference photo, and we can do every step by step. Go back to the Visio. This is the Visio we're working on right now. You can just paste the picture over here. Okay. So the first thing we have is an inlet to the absorber. Then we want to add the actual absorber. So the actual absorber, we get it from the vessels. Where's the absorber? This one. This straight line. Okay. We can zoom in to make the actual absorber bigger. Zoom out. And we look for the green box so we can connect the absorber to the line. Let's change the display. I don't like it. So let's go for the light. Okay. We need more lines, basically. So the next thing we need another pipeline that's leaving the absorber from the bottom. So we're going to start with this control loop. So another pipeline. Here's another major pipeline. We can directly connect it over here. Okay. Then we need a pump. Usually whatever is leaving the absorber from the bottom, it's a liquid. So we need a pump to increase its flow rate. Then we move on to the control loop that we're working on. We did not add pumps. So we go back to engineering. We go to process engineering, and then we add the pumps. So we can take a centrifugal pump, and we can add it over here. We can connect the two with the green box that pops up. Next, we add another pipeline. This pipeline will have the control loop on it. So in order to make this a bit, let's say, easier, first we're going to add the valve. So the valve that's here is a screw down valve. So we add it. Then we add a connection between, we go back to home. We add a connector between the pump and the valve from here. Then we can go back to the pointer tool, and we can add a pipeline that is exiting the final. Here's pipelines. Okay, so another member pipeline, which is right here. We can add it to the valve, the main pump. Perfect. Now, let's add this control loop. This control loop has backup valves and the valve that the controller works on, or the control sends signal to. So in order to add those valves, we'll go the valves and fittings, but we're not going to use the same valve. First, we're going to use two gate valves, which is located over here. Here's one, copy, paste. Here's two. Then we're going to add the main valve that the controller works on, which is a diagram valve. And we add it over here in the middle. We're going to connect all these three together using the connector up here. So we connect from this side. It makes it easier. We will connect from here, here. Then we connect these. Always look for the baby green box. Then we can connect this to this. Now let's work on the level control loop. So the level control loop, since this has a liquid, this liquid has to be in a certain level in order for the absorber to work properly. So the first thing we need is a level indicator, a level transmitter, and a level indicator controller. So let's add all of those. We go to instruments and we add the indicators. Here's the first indicator. And here's the second indicator. And here is the third indicator, directly above the valve. Now, in order to connect those indicators together, the first indicator, which is the first thing we need to connect is the level indicator. So we use a normal connector for that, but the rest we have to use other ones like electric and pneumatic. This is a normal capillary connector. We go back the pointer tool. Let's zoom in. So it makes it a bit easier for us to connect. Now, if we double click on each one, we can simply name it. So this is a level indicator. This is a level transmitter. And this is a level indicator controller. Level indicator controller. Now, the signal that the level indicator sends to the level transmitter is actually an electric signal. So we look for electric 3, which is this one. We drag it and we add it over here. We add it over here. And the same type of signal is between the level transmitter and level indicator controller. So we copy paste it and we add it one over here and one over here. And finally, we need a pneumatic signal, which we can find it over here, in between the level indicator controller and the valve. Oh no, not here. Here. Yep. And then over here. So this way, we have this control loop, which is a level control loop ready. So as we said, we have a level indicator, transmitter, and a level indicator connector. If the level in here is too high, the level indicator will indicate that the level is too high, and it will send its signal all the way to the controller. The controller will order this valve to increase its opening and allow more liquid to flow out, so increasing the flow rate leaving of the liquid, and therefore decreasing the level, and vice versa. If the level is too low, it will just order it to decrease its opening, so the level inside the absorber will increase. Now, what if we have a situation where we need the like something goes wrong with the controller, let's say, or with the loop itself. So we need this. This is a drain. A drain is very simple to add. You just have to add a valve with a gate valve with I don't think there is actually just a drain. Yeah, a gate valve, and then you rotate it. You zoom so it can make it a bit easier. You get it close to the absorber, and then you just add connectors in between it and the absorber and then leaving. You can just add an arrow leaving, it doesn't matter. So this is a backup, it's a drain for emergency reasons, or maybe for maintenance or whatever the case is. Next, we need, let's talk about this. This loop is a pressure control loop. So whatever is leaving the top of the absorber is actually a what? It's a gas. So therefore, uh, if the concentration if the amount of gas inside the absorber is way higher than normal, it's obviously going to increase the pressure inside the absorber. So this is why the pressure control loop is on the top of the absorber. So first thing we're going to add is just a pipeline leaving the absorber from the top. So here's a major pipeline, and we're going to connect it to the top of the absorber. Perfect. So now we add this valve connections the same way we did over here. For this way, we can actually easily just, or you know what, let's just do it. Okay, so first thing we're going to need is